This question says the graph of a function where the real numbers maps to real numbers of f of x is e to the power of x over 3 plus 1 is shown. The normal of the graph of the function where it crosses the y-axis is also shown. What steps are needed to be taken to find the area of the shaded region? Now, let's work backwards. The area of the shaded region is what we want. Now, if we get the area underneath the curve, it will give us this big green area. So one of the steps we need, I won't tell you which one at the moment. One of the steps is the area from 0 to A. I'll just put A underneath the e to the power of x over 3 plus 1 function with respect to x. Now, we don't want the area all the way to the x-axis, so what we would have to do is then get the area underneath that line, and that step we would get from 0 to the value a for that normal function with respect to x. And when we've got that number, we would subtract, so that this area, we would then subtract, I'll just put here, minus, and then that would give us the area of our shaded region, which is what we're looking for. Now, we need this formula for the normal. So the normal has a gradient at right angles to the curve at x equals 0. So at x equals 0, what is the gradient of our function? Now the gradient of our function is the derivative at 0, and that would be, and the derivative of this function is e to the power of x over 3 times by the derivative of that bracket, which is a third, and the derivative of 1 is 0. And if you substitute 0 in here, so this is an x, so if you substitute 0 in that equation, you'll get e to the power of 0 times a third, which is a third, which is a third times 1 is a third. Okay, so the area of that green is, oh sorry, no, that's just the gradient of the curve at x equals 0. Therefore, the gradient of the normal, of our normal, is negative 3 over 1 to reflect the 1 over third, negative 3 over 1. And it crosses the y-axis at 1. So this equation of the normal is y equals mx plus c. All right, so there is the equation of the normal, and this is what we would use. We would get the integral of negative 3x plus 1 with respect to x. And to find what a is, that is where the normal crosses the x-axis. So the x-intercept is when y equals 0, and it would be negative 1 over negative 3, therefore x will equal 1/3. So that's the value 1/3. And we would go from 0 to 1/3 That value is 1/3. That value is 1/3. That value is, now we know, is 1/3. And that's the steps we would need to take to get these. And what definite integrals will be needed? Well, what is the definite integral here? Let's go between 0 and 1/3. The definite integral of e to the power of 3x is I don't need that symbol because I'm going to work out the definite integral. So the definite integral e to the x over 3, you leave it. And then because it's the integral, we divide by 1/3. And the definite integral, the integral of 1 is 1x. And that's from 0 to 1/3. And the definite integral of this part here will be the definite integral of negative 3x is negative 3x. You raise the power of 1 up to a 2, and you divide it by the new power. The definite integral of 1 is 1x. It's from 0 to 1/3. And there it is. Remember, you would get this answer minus this answer, and that's the steps you need to take. I will follow up with the actual answers, but the answers are not part of this module. Calculating area is not part of this module, but working out the integral of e to the power of x over 3 plus 1 is part of this module.